Hi there. The purpose of this video is to explain how learners may successfully evidence the Pearson BTEC HNC Engineering Unit 1 Engineering Design. This video follows on from the video regarding Unit 4 project. This assignment for Unit 1 gives the learners the opportunity to develop skills in executing a design project. Unit 4 is more aligned with project management. In Unit 1, there are 9 pass criteria, 5 merit, and 4 distinction. I would guide that the learners should tackle Unit 4 first and then do this Unit 1, because in Unit 4 there are less criteria and the criteria do link together across pass, merit and distinction more effectively in Unit 1, plus the fact that learners will already have had exposure to understanding the power of having a basic written plan. They understand how to choose a solution through SWOT or a decision matrix already, and those skills can be applied in Unit 1 also. My guidance would be to initially start the report by evidencing P2. So the reason I'm saying to start off with an introduction that will cover P2 is so that the learner can understand and also explain that a design brief is generated by a customer, and the professional role of an engineer is to analyze that design brief and create a design specification that will provide details of how to design, build, test, and produce a working product. So there are different ways to describe the design loop. This is done with an iterative process or a design loop. You identify the problem, define the requirements, which is your spec. So the design brief is customer generated, and the role of a professional engineer is to advise and guide the customer as to the legal, safety, pragmatic, technical aspects, what is possible in terms of taking that design brief and producing a design specification that is achievable. So that may require going back to the customer and explaining that certain aspects of the brief may not be technically possible, or for example, they may not meet legal requirements. And that is one aspect of being a professional engineer, is to guide and advise the customer. I would advise that Unit 1 design is given as a single assignment so that it promotes holistic assessment, so that it encourages learners to be aware and link things together on how different aspects of their learning relate to each other and support each other. And it's a reminder that assignment evidence must, if we can spell that properly, apologize, must be valid, authentic, relevant, sufficient, and appropriate. So my advice would be, as an introduction for the learner, to explain the difference between a brief and a spec. So the brief is customer generated and the spec is generated by the engineer. The spec is likely to have between 8 and 10 elements in it. For example, form, function, ergonomics, materials, engineering processes, so on. It is a blueprint of what the product needs to achieve. The guidance next would be, once the learner has evidence P2, is to then tackle the design plan. Again, similar to what is in Unit 4, I would recommend that a very basic plan is put down as a written plan. So it's KISS, keep it simple and sane. Just get the appropriate elements of what is required to execute the project, get it down in bullet point, provide some detail with very basic timelines, and then that could be developed into a more graphical working plan. For example, an Excel form that you provide a bar chart, and that is used as a working plan. So how do we take the brief to a spec? Customer-driven brief. The engineer needs to analyze that brief and develop a design spec. So 5W1H would be a technique to analyze what, where, who, when, and why. That was developed out of a Kipling program. Very simple technique. The simplest techniques tend to be the most effective. The justification for keeping a simple plan are all these things identified here. You want to keep it simple. You want to map out at the earliest possible stage in the project, identify all the necessary tasks. And if you do that, get them down on paper, make it open and transparent, you will maximize the probability of your success. And again, written plan means that it can be analyzed, it can be given to multiple stakeholders, people can reflect on it, it can be evaluated at the end of the project as to what went well, what didn't go well, and change the format of the plan to the context of what you're doing. Design spec, what needs to be in a design spec for P1? So form, function, generally speaking in engineering terms, form is not necessarily important if it's in the industrial setting. So we're talking about color, shape, but it may be important in certain contexts. For example, cars, people like particular shapes and colors of cars. Function, is this going to be an automated system? The input and the output signals, processing required, response times, quantity, sustainability, materials, manufacturing processes, ergonomic considerations, as in how easy it is for humans to use, human-machine interface, safety aspects, cost, timelines. That would be typically in a design spec that can be fleshed out depending on the context of the vocational scenario that is given to the learners. So it is crucial in the assignment brief that the learners are given a vocational scenario that enables the learners to identify a professional context. As a single assignment, the guidance is 7,000 words. That's an indicative figure. It's not a target. What we're saying to learners in that figure is it's highly unlikely that you can successfully evidence all criteria, all 9 passes, 5 merits, 4 distinctions in 1,000 words. That's an indicative figure. Obviously, it's quality over quantity. What we're also saying to learners is that if you're targeting the higher grades, you can give 10,000 words that only describe, but that is not going to provide the evidence for merit and distinction criteria where you're typically asked to explore, explain, analyze, and evaluate. It's an indicative figure. So if your standard of English and grammar and presentation and technical terminology is of a high standard, you may be able to successfully evidence all criteria in, say, 4,000 or 5,000 words. It's simply an indicative figure. So yeah, we need a design specification. Once the design specification is completed, I would recommend evidence in P4, which is industry standard evaluation and analytical tools to tweak out the best technical solution from a range of possibilities. So the range would be a minimum of 3 potential solutions, and you pick the best one objectively. How do you be objective? Then you want to minimize bias and subjectivity. And the way to do that is to use various standard techniques, which are proven standard techniques used in industry: a decision matrix, a weighted decision matrix, 3 columns with 3 different solutions, and you choose criteria, say 6 criteria, and you weight it 1 to 5. And at the bottom of the column, you add all the numbers up against the criteria, and the highest number is the chosen solution. Strengths, weaknesses, opportunities is effective as well. PESTLE may be effective, but it's more aligned with perhaps, say, renewable energy projects, where its political, economic, and social aspects are very important. It's not just about the economics of money. Pareto is another technique, and 5W1H. Again, keep KISS in mind, the simplest, keep it sane and simplest, sane and simple. The simplest techniques tend to be the most effective. Again, yes, fleshing out P4. Objective is the most important word. We want to be objective as engineers as possible, so that we minimize emotions, biases, and subjectivity. And that's the whole purpose of showing proper process and methodology. Yeah, there are lots of different analysis tools. Again, I would tend to use the simplest ones because they tend to be the most effective, but depending on the context of the project, you may want to step up and use more complex decision-making tools. Thank you for watching this video. Again, it's important to reflect at the end. And again, that's what these distinction criteria are there for in terms of D3 and D4. So it says evaluate the effectiveness of your design report for producing a fully compliant finished product. So again, we're talking really about here, we're really taking our original design spec and what would be required to have a fully compliant product spec in terms of all the testing that's required in terms of building a fully compliant product that can be sold on the open market, so that you've identified the voltages, the currents, the temperature rating, all the safety requirements. And final conclusion would be D4, to justify improvements to the design solution and/or presentation techniques, and so that you can reflect, absorb feedback. It's very important to have feedback from different sources, to be open to feedback so that you can grow and improve. And on the next project, you can further improve your efficiency and productivity going through a project. So Unit 1 and Unit 4 do dovetail together. My guidance would be for the learners to undertake Unit 4 project first. And once that's completed, then undertake Unit 1, which is a design project, so that they get the full range of experience on different types of projects. Thank you for watching. Any comments, please provide in the box below. Thank you.